All right, we're live. Should I watch the video, or we'll watch the video?
Question 5, in no less than 3 sentences, please define and describe the 68, 95, 99.7 law. Okay, so this 98, 95, 99.7 rule is something that's really, really helpful. And I'm going to use kind of a graphic.
Problem 6.
Question number 6. Scores on the quantitative portion of the GRE are approximately normally distributed, with mean mu equals 150.8 and standard deviation of sigma equals 8. Okay, those first two numbers are pretty easy to get. They just come straight from the chart right there under the GRE scores. Okay. Now, part A says what proportion of the people who take the quantitative portion of the GRE will score above 165. Okay, so if you remember our z-score up here, the formula, we're going to use that to solve this question out. So our 165 is the score that we're looking at. It's the observed score that we're going to be testing, minus the mean, the mu, which was 150.8, divided by the population standard deviation, which they told us was 8.8. Okay? So when you plug that in to the calculator, you come out with 1.6136. Okay? And then in order to find out what proportion of the people who take the GRE will score above that, we're going to take this z-score, we're going to plug it into the normal probability applet.
Oh, okay.
So here's the normal probability applet, and if we plug in the z-score that we just got, the 1.6136, get it. And we want to make sure that we shade this upper portion because we want to know those that scored above that. Then we get 0.0533. Okay, so that area
Did you get that?
represents the percentage the portion of people that served, or that, that received a score higher than 165. Question B. If a student score is in the 10th percentile, what would their corresponding z-score be? Okay, so this one is actually found by just simply using the applet.
Did you skip?
Over here on the applet, let's highlight the area that we're looking for. We are looking for the 10th percentile. So we know that's going to be less than half. So we only need this very bottom one. And we're going to be typing in the area that we're looking for. Okay, that 10.10, which represents the 10%.
Okay. So he is typing in 0.10 at the top.
In the area, okay.
And then he unhighlighted the blue.
Uh-huh.
And then I can't see if he did anything.
What did he put in the top? 0.10? Or what was it again?
These group right here scored they are the low, the applet.
Okay.
So over here on the applet, let's highlight the area that we're looking for. We are looking for the 10th percentile.
Okay, so first he clicked on the bottom left to make it blue.
Uh-huh.
And then
we know that's going to be less than half. So we only need this very bottom one. And we're going to be typing in the area that we're looking for. Okay, that 10.10.
So it's 0.10.
Okay. And then do you press enter?
Yep. Okay, let's keep going.
Which represents the 10%. So these group right here scored they are the lowest 10%, or the 10th percentile. Okay? So in order to find the z-score, you just type in there and it pops out right here. So the z-score is -1.28
that what you got?
Negative 1.282. Yep.
Okay, so that's C.
Yeah.
Sweet. Okay.
What is the quantitative GRE score for a student who scores in the 10th percentile? Okay, now we're going to take that last question and take it one step farther. So we have our classic Z-score, but now we have the Z-score, and we have the Z-score, but we're missing the value. That's what we're looking for. What did that 10th percentile student score? So we input what we know. And we know a few of these values. So we know that the Z-score is the negative 1.2282 is equal to, we're going to be solving for X, and we're going to minus the mu, and the mu hasn't changed, so the mu is still 150.8. And the standard deviation is still 8.8. So as we rearrange this equation algebraically, we're going to bring across the 8.8.
Multiply it.
So then we have this X equals minus 150.8. And we add that over, and I'm just going to switch the sides. Well, and so we'll get 8.8 times negative 1.282 plus 150.8 is equal to our X. Okay?
That's just all.
You plug this part into your calculator, and the score is 139.5. Question 7.
Okay.
I totally didn't get that one.
Okay, so what he did was, since we didn't have X or whatever it's called, I don't remember the fancy name for it. So we have Z, so we put in negative 1.28 for Z, and then equals, and then he just kept the X.
Oh, okay.
He just like put in the numbers that he did have and solved for X.
Right. Okay.
So I don't remember what he said the answer was. Let's see if we get this.
150.8 is equal to our.
Okay, so the equation is 8.8 times by negative 1.282, and then you add 150.8. And the answer is, I got 139.5.
And you add?
Yeah.
You add 150.8. Is that what you said?
Yep. So I'm going to see what he says the answer is.
X. Okay? You plug this part into your calculator, and the score is 139.5.
Sweet.
Oh, that's not what I got. Okay, so you bring the 8.8 over and times it, multiply it times 1.282, right?
Negative 1.282.
Oh, that's right. That's probably what I did wrong. Okay.
So you want X by itself. You're solving for X.
Right. What was the answer? 139.5?
Yep.
Okay. That's what I got.
Did you get the answer for B?
For B?
Yeah.
Yeah. 0.0533.
0.0533. Oh, that's what was on the bottom half, right? Oh no, above 165. So is that when we did the template thingy?
Yeah.
Okay. All right, she's gonna go on.
Question 7. The mean speed of hydrogen at room temperature is 1,800 meters per second with a standard deviation of 600 meters per second. Part A, at room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of mu, 1,800 meters per second, and a standard deviation of 600 meters per second. Okay, now remember that those are the values that were given to us in the problem. Part B, what is the probability that a randomly selected particle has a speed of over 2,500 meters per second? Okay, so now we're going to come back to our z-score formula. We're going to look for the z-score because we need a z-score in order to plug it into the normal probability applet. So our z-score, our value that we're looking at is 2,500. We want to know how many that the particle has a speed of higher than 2,500, minus our mean, which is 1,800, divided by our standard deviation, which was 600. Okay, so we plug that into the calculator, and we come out with 1.16. Okay, and now this is our z-score. Okay, so they scored 1.6 standard deviations above the mean. Now, if you think about it, this makes sense. Let's just break this down just for a second here. If our mean is 1,800 and one standard deviation, which would be a z-score of 1, is 600, and if you went 600 above 18, you'd be at 2,400. And we were at 2,500. So the fact that we got a little bit above 1 should make sense. Okay, now we're going to plug that into the normal probability applet. So we come over to our applet, and this time we're concerned again with which is faster. We're looking for a faster speed.
Okay, so he highlighted the right and unhighlighted the left.
Okay.
So far.
For this portion right here, and we need to type in our value of 1.167.
Okay, and then he typed in 1.1667.
In the right?
Yep.
Okay.
The corresponding area, which also represents the probability of randomly selecting a particle with speed faster than 2,500, is 0.1216.
0.1216?
Yeah, so that's the answer for B?
Hang on.
Or 12%, or say about 1 in every 8 or 9 times. Question C.
Yes, that's the answer. So the answer would be, what is at the top?
Right.
So it would be 0.1217. Right?
Okay. So why do we say 1217? I thought it was 1216.
I think he rounded it.
Oh, the next, okay.
Yeah. Yeah, that's weird. I'm not sure why it says 0.1217 because in the answer it says. I don't know. Okay.
What is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? Okay, so our probability that it was probability that it was faster from the last question was 0.1216. And what's cool is that if you remember from our rules about probabilities, the probability that it was slower is just 1 minus that number.
That's cool. Does that make sense?
I'm sorry, I was looking at the notes. I was looking at the textbook thing. What did he say for C?
He said because the probability of it being faster was 0.1216, the probability of it being slower is just 1 minus that number.
Oh, right, okay.
And so the answer that there is just simply 0.87. 0.878. Okay. And that is a simple way to find, because remember, the probability that it is 1 minus the probability that it's not. And in an earlier example, we talked about dice.
That's
The
nice.
probability of rolling a 5 on a dice is 1/6. The probability of not rolling a 5 is 1 minus 1/6, which is 1/6. Good.
That's cool.
Oh, yeah, okay.
What is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? Okay, so we're going to run a z-score again. Hopefully this is becoming pretty second nature. So 1,500 minus our mean of 1,800 divided by our standard deviation of 600. Okay, that gives us a z-score of negative 0.5. Okay, that makes sense. You get negative 300 divided by 600. It's negative 1/2. Okay, so we're going to take this z-score and plug it into our normal probability applet. And this time we're wondering what the probability of getting less than 1,500 is. So we're going to select.
Okay, so he unhighlighted the right and highlighted the left.
Okay.
Small area there, our low one, and plug in negative 0.5.
And highlighted and plugged in negative 0.5.
We have an area of 0.3085, or in other words, a 30.8% chance of selecting a particle at random that has a speed less than 1,500 meters. Part B.
What? How did he get 30.85?
That's what's at the top.
I have 0.3085.
Yeah, so that's what it is in decimal, but then he just said if it was a percent, it would be 30%.
Oh, okay. Okay.
So, okay.
All right.
What is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500? Okay, so we're going to kind of show this graphically. I think this will help you visualize how this is going. So our probability here at the beginning that a particle would have lower than 2,500 was 0.8783. Okay, so this whole area from here to there was 0.8783. Okay. Now we did another one, and we found that the 1,500 mark was about right there. And the value in this area, right here, the smaller area, was equal to 0.3085. Okay, so we have this whole one and then a small one. Now what we're looking for in this problem is how many people,
Oh, so you're just going to
or how many particles are in between those two values.
0.3085.
Okay, so since we have the big one,
0.878.
we're going to take the 0.8783, and then we're going to subtract off this part. So we're not worried about these people.
Okay.
So it's minus 0.3085. Okay, so you subtract that, and you get your answer to be 5698. 0.5698.
Is that what you got?
Okay. And that right there is the probability of finding a particle between 1,500 meters per second and 25
So
meters.
he subtracted 0.3085 from 0.8783, and then what did he do?
That was the answer.
Oh, so it's 0.569?
Yep.
Okay.
That was, what number was that?
That was E, right?
I believe so. Yeah, so 0.5698 is the answer. Okay, last part.
Per second. Question F. What is the third quartile of the speed of hydrogen at room temperature? Okay, so now remember, the third quartile is the 75th percentile. And up here in our applet, the 75th percentile can be represented by an area of 0.75. Okay? So we
Okay,
have this area.
so he's back in the template or whatever,
Uh-huh.
and he highlighted the left two columns.
Right.
And then up at the top, he put 0.75.
Okay.
0.75. Now, since we're looking for a value, we're going to take this z-score and we're going to move it into our formula. So there's this. So our formula is as follows. We have our z-score of 0.6745 is equal to our x value, which is what we're looking for, the x value at the 75th percentile. Remember, this z-score represents the 75th percentile, minus our mean, which is the 1,800, divided by our standard deviation, which is 600. Okay? You do your algebra, and you get x is equal to 600 times 0.6745 plus 1,800. Plug that into your calculator, and you get x equal to 22.04 meters per second. Okay, now remember that represents the third quartile, and that third quartile means that 75% of the particles are as slow or even slower than 22.04. Okay.
Okay, I don't get how we got that again. Was it 0.6745 minus 1,800 divided by 600?
No.
Okay, what?
So he just did the z-score formula. So it was 0.6745 equals x minus 1,800 divided by 600. So he just wanted x by itself, and it ended up being 600 times 0.6745 plus 1,800.
Okay, so you said 0.6745 equals x minus 1,800 divided by 600? And then, so you have to times 600 times 0.6745?
Yep.
Okay. And then that number you subtract from 1,800?
Hold on. No, you add 1,800 to it.
Plus 1,800.
It should be 2204.
Yeah, that's what I got.
Okay.
Plots. Okay. Plot A is obviously not normal. Plot B is also not normal. That little S curve disqualifies it from being normal. C is normal. Now, although it's kind of got some bumps in it, the bumps are consistent, and you can draw a line through it, and there would be even dots above and below the line. So we consider that normal. D is normal, nice and straight. E is also normal, and F is the most normal of them all.
All right.
What was A, B, and C? I didn't catch that. Are they not normal?
A and B are not normal. C is normal.
Okay.
Because he said if you can draw a line, then it's normal.
I got it. Okay. I get that. So we're done.
Yay.
Are we ready to take that quiz though?
No.
Because can we use notes and stuff for our quiz? I can't remember.
I don't see why not.
Oh, yeah, we can.
Yeah,
Okay, should we do it?
sure. Doesn't he do it on the video too?
Oh, yeah, I've got the answers.
Yeah, so like as long as we work it through, we can, yeah. Okay, ready?
Yep.
Okay. This is going to be the longest meeting ever.
I know. I'm getting hungry.
I know.
Okay. The total area under a density curve must equal 1, right?
I think so.
Hold on, let me find my answers.
Under a density curve.
Yep. Okay. Under certain circumstances, a density curve can drop below the x-axis.
Isn't that false?
That's false, yeah, because it says the density curve always lies on or above the horizontal axis.
Right.
A normal density curve is symmetric.
True.
Okay, how is that? Why is that?
Oh, wait. I'm thinking bell curve. What's the difference?
Density curve. Oh, this is not the answers. Hang on. Normal curve is always symmetric.
Okay, that's what I thought.
All right. I'm still unorganized. Okay. Use the following image to answer questions 6 and 7. Which of the following elements of the figure represents the z-score in this image?
Isn't it C?
I think.
You have the answers?
Oh. What number is that? 6. Yep, you're right. Which of the following elements of the figure represents the probability that the random variable z will be greater than
We start the recording now.
1
Go ahead and
Stop. So, sorry, what was the question? Which of the following elements of the
Which of the following elements of the figure represents the probability that the random variable z will be greater than 1.000?
Isn't that B?
Yes.
Okay.
According to the 68-95 99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
68.
Oh, yeah, okay.
Is that right?
Yes.
Okay.
All righty. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of values from this random variable will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places.
Okay, so we just type in -1 and 1 in the template.
Oh, shoot. Oh, yeah. Okay. -1 and 1.
Okay,
Do we have any of them filled in?
hold on. Will be between 1 and 1. So I'm assuming we fill in the middle part. I got 0.6827.
Yep.
Is that right?
0.683. Yep, that's right.
Hey, I actually understand this stuff.
Well, I'm glad.
It's the
I'm
SPSS that I struggle with.
Not quite yet. I'm still.
Okay, suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2? Is that the same thing? We just change the numbers?
Yeah, easy.
So I got 0.955.
Yep, that's what I got.
Is that the
Is 0.995. Yeah.
0.995 or 0.955?
0.955.
Okay. I feel like all we have to do for the next one is plug in -3 and 3.
Mm-hmm.
And it's 0.997.
Yep.
Look carefully at your answers to the last 3 questions. What do you observe? I would say A. Because it's 68, 95, and 997.
Yeah. Yep, that's right.
Okay.
Ugh. Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the grams of good quality protein that must be consumed each day per kilogram of per kilogram body of weight. The population mean protein requirements for adults is, and the population standard deviation is. Use this information to answer 14 through 17. 13 through 17. Okay. What proportion of the population have a protein requirement that is less than blah, blah, blah?
Okay, so the population mean for adults is 0.6. So like this when we do the z-score?
I have no idea.
The amount of protein that an individual must consume.
Yeah, we do. Yeah, I wrote it down. I wrote down.
So z equals 0.60 minus 0.66 divided by 0.07. Is that right?
0.6 minus 0.66 divided by 0.07. and then that equals negative 0.857.
Okay.
And we put that in the applet.
Oh, okay. As where? Less than. So it would be on the bottom, right?
Hold on just a minute.
Also because it's negative.
Remember less than and greater than signs on normal applet to fill in greater or less than. Okay. So less than is the left.
Right. So minus 0.8.
0.857.
Okay. So is it 0.196?
Hold on, I entered the wrong thing. Okay, 857. So I got 0.609.
Okay, that's not what I got.
Wait, what did you get?
So I put in the bottom left negative 0.857, I believe.
Uh-huh.
And then I highlighted the far left because it says less than that. And then the area at the top gave me 0.196.
Oh, that's right. I still have the center filled in.
Oh, okay.
Yeah, and that's right. That's the answer.
That's what the answer key says?
Yep.
Okay. So then the next part is exactly the same. We just highlight the right, correct? Which is the exact same number.
The answer's not the same. Is that what you mean?
Oh, wait a second. Hold on. What proportion of the population is more than 0.6? Okay. So wait. Do we highlight just the far right or the middle and the far right?
More than. So I think it's the middle. Yeah, it's the middle and the far right.
Okay, so the answer is
0.804.
Okay.
Yeah.
Oh, because we found the z-score for that, right?
Yep.
So is that the answer?
Yeah, 0.804.
All right. What proportion of the population have protein requirement that is less than point? Okay, so we have to redo the equation, correct? It would be 0.7 minus
Oh, yeah. Okay.
0.66 divided by 0.07 equals, I got 0.571. So then I'm going to put that in the far left. And then highlight the bottom or the far left. And then I got 0.284.
And you highlighted which one? The everything from.
So what I did was I put the z-score in the far left one, and then I highlighted the far left. But I don't know if that's right. Is the answer 0.284?
No.
Okay. Then, what proportion of the population has protein requirement? Oh, maybe.
Oh, you have to do the center and it's everything, the center and the left.
Oh, really?
You have to highlight both of those.
So is it 0.716?
Yeah.
Well, that's weird. That doesn't make any sense.
Because, let's see. What proportion of the population?
Oh, yes, it does, because it's a positive number. So because it's a positive number, it goes on the right of 0. That makes sense. Okay, I get it.
Okay.
You get it?
Not really.
because it's 0.571, it's greater than 0, so you put it to the right. But if it was a negative number, you would put it to the left in the z-score.
Oh, okay.
So is the answer 0.716?
Yep.
Okay. Oh, find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 7. Remember that to find the area between two values, shade to the left of each. Okay, so they're randomly selected. So do we put 0.6 and point? No, that wouldn't work. Hold on.
Find the probability is between.
Oh, wait a second. So we already have 0.7 in the right. That's 0.571, right?
How is that 0.7? Oh, I get it. Okay.
0.571. And then do we put in the 0.6, the score that we got on the left, and then shade in the middle? I don't know. I'm super confused.
But you can't put two different scores, can you?
I don't know. Calculate and subtract. I'm not sure.
Oh, okay. So do we enter 0.804 and 0.716? Because the area between the two values, what proportion?
So you can't have a different z-score. I don't know.
Yeah, I don't get that one. Let's see.
Find the probability that a randomly selected person. Okay. Oh, wait a second. Remember that to find the area between two values, shade to the left. Oh, okay. So we have to find each of them again. Wait, we already have the numbers. Then subtract the smaller area from the larger area. So would it be 0.804 subtracted 0.716? I have no idea.
That's what I was guessing, yeah.
Yeah. I got 0.88. No, sorry, 0.088.
Yeah, that's what I got. Okay. But that's not all we do, right?
I'm not sure. What's the answer? And let's try and find the answer.
The answer is 0.520.
Okay. So find the probability that a randomly selected person will have a protein. Okay. How about so 0.60. Okay.
If you enter 0.088 into the, the z-scores down there on the applet, then the area is 0.5351. I mean, it's not 0.520, but it's really close. I don't know if that's just a coincidence or if it's...
Wait, what? Okay, that's not what I got. 0.088 on the right z-score. Oh, okay, you highlighted the bottom two. I gotcha. Okay, find the sorry, can you tell me what the answer is again? So I can just try and...
0.520.
Okay, so 0.52.
Oh, but wait. Okay, then it says
I have to subtract. So,
shade to the left of each z-score.
oh, okay, I get it. So, we're going to find each of those. So, let's do the 0.61. I'm just trying to figure this out. Minus 0.66 divided by 0.07. So then we plug this into our template. So it's minus 0.85, and then to the left, right?
Mm-hmm.
So we want to know, what's the question? Between 0.67 or 0.6 and 0.7. So I'm assuming we're going to take this, which is 0.1977, and then we're going to find the next number, and then we're going to subtract this because it's smaller from, I'm just guessing. I don't know. Did that make any sense?
No, I'm just looking at the answer sheet.
Well, I'm going to try this and see if it works. 7, okay, I'm just going to try this. Bear with me.
So what are you doing? Tell me.
Let me see if this works, and then I'll explain it to you, because if it doesn't, then there's no...
Okay. Okay.
Okay. So 0.82. 0.8. Okay, so okay, this is just a ballpark guess, but I'm trying to figure this out. Ah, dang it. We're so close. 8, 0, 2, 3. Dang it, I was hoping that would work. Okay, hold on. You might just have to watch this video. Find the probability the range is between 0.60. Oh, wait a second.
Smaller area from a larger area.
Not what would be between this. Okay, let's try this. Let's try 0.6. 0, 0, 7 minus 0.9.
Then subtract smaller. I totally don't get this.
Okay, I'm attempting. Ah, dang it. Okay. So I felt like what we were supposed to do was find each of the z-scores for those numbers, and then highlight. You know what? I'm just gonna watch this video and see what he says.
I think I want to watch the video. Yeah.
Go to the group meeting on lesson 04.
Is this
And
group
in
meeting?
lesson 04, we will be discussing.
Oh, this is
No, you want to fast forward through it. It's like an hour and a half. And lesson 5 is at the end.
Is the proportion of the probability less than this z-score of 5.71. So I'm going to type
I'm not
this
sure what
number
number
here.
he's on right
This
now.
probability. The standard deviation is 10. And then you want below, click below. And you
Oh
do
wait, he also
50,
does the homework, right?
And your
Yes.
answer, you know,
So the quiz thing is at the very end.
Oh, it is?
Yep.
and the area, it says is 68%. So you just type in 0.68. The outlet.
I think the quiz is at the
Lastly,
beginning,
when
and
we
then the
needed,
homework is at the end because he's
paste
doing
it
the
here.
homework. Not the beginning, but the middle. So he does the.
That's true. The homework thing will be at the end. So the group one should be right before that somewhere.
And then we want
Okay.
That is less than 0.7 grams.
Okay, so this is number
So-
15.
0.7 is our data. Let me
So
just
it's right
copy
before
this
16.
first. Okay.
I'm so frustrated. I wanted to figure it out.
I need to change the x to be 0.7 this time. And then it automatically computes. Let me do this to be red. The red one is the result. Black one is what you need to enter. So the z-score for 0.7 is 0.571. And it says we want less than this. So this is a positive. I'm going to copy that and then paste it here in our normal outlet since it's positive. On the right side, Control D, enter. And then we want less than. So less than is to the left of 0.71. This one. And that is 0.716.
Hey, we got that right.
Control
Yep.
C for copy.
Okay, now I just gotta
Control V
figure out
for
this
paste.
lasted 16.
16.
It's so awkward because no one reads it.
I know.
Randomly selected person will have a protein requirement that is between 0.6 and 0.7 grams.
Okay, so between 0.6 and 0.7, and the corresponding z-scores for 0.6 is this, negative 0.857. And for 0.7, the corresponding z-score is 0.57. We want between those two. Now, this outlet, we cannot make them different. You can see they're
Okay.
always the same, but it's a negative and a positive. So how can we obtain the probability between positive 0.71
Oh, wait a second.
and then, but the below one is negative 0.857, because if I change this to this from this number and change this, you could see that it automatically changes to the other positive number.
Right.
So I'm assuming what you do is you find the in-between, just the in-between for each of them, and then subtract that instead of all the way to the left. Hold on, I'm just going to attempt this real quick.
Okay.
So in between right now is 0.6047. So 0.6047. And then if we change it, if we cut it up here. So that's the 0.85. And then he's got 0.571. I just really want to figure this out.
Where's he getting 0.571?
That's the z-score that we found for the 0.7. Okay.
I thought it was 0.716.
.422. Well, that's not going to give me 0.5. Okay, whatever. I'll just watch it and see what it says.
How do we do that? So the first thing is we want we start with a high number, 0.571 z-score, the higher z-score. That's the top. Enter. And I click everything to the left.
Oh, everything to the left. Okay. So what he did was he put in 0.571 to the template, and then he clicked everything to the left. So it gave him 0.7160. 0.7160. And then I guarantee you he's going to subtract
What did you get for the area then?
0.7160.
Everything to, oh, okay. Yep, I got that.
Okay, let me see this. 0.7160 minus 0.1960. Did you say it's 0.52?
Yeah.
I think I figured it out. Okay, let's make sure.
How do we do that? So the first thing is
Oh gosh, stop talking.
I'm still confused about this 0.571. Where did it come from?
Oh, where did the sound go? Oh, the 0.571 is just the z-score for 0.7.
now this applet, we cannot make them different. You can see they're always the same except it's a negative.
Man, I
and a
better ace
positive.
this class with how much
So
time
how
I'm putting
can
into
we
it.
obtain
I know, it takes so much.
probability between positive 0.71 and then, but the below one is negative 0.857, because if I change this to this number, from this number, and change this, you could see that it automatically changes to the other positive number.
Okay.
So how do we do that? So the first thing is
These recordings could go by so much faster.
we start with a high number, 0.571 z-score, the higher z-score.
Okay, so he highlighted
That's the positive one. Enter.
the left.
And I click everything
left
to
of
the
that.
left of the high z-score. And I get 0.7160, which is the proportion of the probability less than the z-score of 5.71. So I'm going to type this number in, this probability. I'm just going to put it here, copy and paste. That's 0.16. And let me do that as probability. And then for the negative, the lower z-score, I do copy that and then paste it here to the left, enter. And
So
since
point
the shaded
one-
region is still to the left. That's what we want. It's to the left.
0.1957.
And the probability of that is 0.1957.
Oh, so I did it right.
Copy.
So then you're just going to subtract 0.1957 from 0.7160, and you're going to get 0.520.
How did he get 0.1597?
So
That's
to
the
find
area.
the in between, we just need to subtract this the higher proportion minus
Okay, I
the
get that.
smaller proportion. So this would be equals 0.716 minus this.
0.520.
So the answer is 0.520.
Right.
I'm going to have to go over those videos again. I'm still not getting it.
Okay, so find the 35th percentile for what? Does he keep going?
And if we want this just to be 3 decimal places, Control C, copy, and this would be Control V. Okay, so that's the last one.
What?
However,
No, it's
before
not.
I end this, there is a template that I actually like better rather than this, that for my class, I have them
Do you have more questions on?
Yes. I don't know what that's all about. Oh. Yeah, he didn't go over 17 and 18.
Really?
Oh my gosh.
Like, no one said anything?
have them use, and let me just show you
I don't think anybody said anything.
this. Let me look
Well,
at
that's
it in my
annoying.
bookmark.
And I wasn't looking at it, so I didn't even know there was 2 more. Dang it.
Okay. But there's several steps. If I use this,
Where do you get that other one from?
I
Just download it?
permit all of this this group meeting and give us the feedback.
Yeah, my group meeting.
I got 100. This is Danielle, and thank you for allowing us to use the second applet because my head started to spin a little bit.
Yeah, the second alphabet is so simpler.
Okay, well, how do we find the 35th percentile?
Oh gosh. I cannot remember.
I'm tempted to email him and be like, there's more questions that you didn't answer, and just save it and have him, I don't know.
I can't believe that nobody said anything because they were all doing it at the same time.
And they got 100 on it, which doesn't make any sense. Yours has 6, 17, and 18, right?
Mm-hmm. Yeah.
I'm just gonna email him. He's gonna hate us.
Call him.
Seriously?
Well, don't you want to know, right? Oh, we can save it. Okay. Yeah, we can just save it and see if he gets back to you.
Because this isn't due until tomorrow. I guess we could call him. My phone's about to die. Do you want to call him?
I don't think he likes me. No, I can call him. Let me see.
I think I'm going to stop the broadcast. This has been long enough.
Okay.